It says each base is 16 centimeters and each lateral edge is 20 centimeters. To help you out, I drew the picture and I marked what everything is. So this is our lateral edge. That's where our L is. And this right here is our base, the base of each triangle. All right, so when I'm looking at this shape and I'm doing surface area, I'm looking at which two-dimensional shapes comprise it. That would be 6 triangles and a hexagon on the bottom. So the first thing I'm going to focus on is our triangle. So let's go ahead and draw our triangle. This is one of our triangles. It has a base of 16. It's got, this is 20. And just remember that the area of a triangle is half the base times the height. So we would have to find this height here. Also, if you know two sides of a triangle, don't look for 60, 30, 90, because we can just use a squared plus b squared equals c squared. Because if I break apart this 16, we break it into 8 and 8. So I have 8 and 8. So to find h, we would just do 8 squared plus h squared equals 20 squared. Well, that's going to be h squared equals 400 minus 64. And then we'd end up with h equals just the square root of 336. And what is 3 square root of 336 simplified down to? Yeah.
Oh, wait, sorry, no.
I'm looking for the exact.
Yeah.
Sangha?
4 root 21.
4 root 21. All right, so now we have all the information I need to do. So if you're on the test and you didn't realize this, you still could have got the answer unless it's not multiple choice. We could have just used the square root of 36 in our equation. So we have 6 triangles. And the area of a triangle is 1/2 our base. Well, our base in this one is 16. So it'd be 1/2 times 16 times our height, which is 4 square root of 21. But we do have 6 of them. So I'd multiply whatever I got there by 6. So we'd have 6 times 1/2, which is 3 times, and that would be 12. And we have 12 times 16. Why am I blanking? What does that come out to? 192 radical 21. So that is our 6 triangles, is 192 square root of 21. That's just the triangles. Now I have to get the area of the base. The base is a hexagon. So we're going to go ahead and draw a hexagon. And the area of a polygon is half its apothem times its perimeter. Half its apothem times its perimeter. So I do need to find this apothem. Your apothem runs from the center to 90 degrees on any one of our sides. Well, the easiest way to find an apothem is to turn it into triangles. And we do know the base of that triangle is 16. So its full length is 16. Which means this is 8 and 8. A squared plus b squared equals c squared only works if I know two sides. If I only know one side, either I missed a side, or it's going to be a 60, 30, 90 triangle, or a 45, 45, 90 triangle. This is going to turn out to be a 60, 30, 90 triangle because we do have this central angle right here. That central angle is going to be 360 divided by the number of sides, which are 6 sides, so that's going to be 60 degrees. So this whole angle is 60 degrees. Break that apart and you have a 30 and 30. So when I bring out this triangle, we got a 90 degrees here. This would be 30 degrees. And this one would be 60 degrees. Because this was 60 to start off with, I split it in half, so we have a 30, 60, 90. Where the one across from our 30 is our 8, that is our S. The one across from our 60 is our S squared of 3, so this would be 8 square root of 3. Well, that's all I needed. Area of a polygon is half your apothem times your perimeter. Well, now I have an apothem, and I have this 16 plus 16 plus 16 plus 16 plus 16 would be my perimeter. In other words, our area for this one is going to equal 1/2 our apothem, which should be 8 squared of 3, times our perimeter. Well, our perimeter would just be our side length, which is 16, times the number of sides. We have 6 sides. That is our perimeter. This is our apothem. And that is going to equal 384 square root of 3. That's all of our triangles. That's our base. So our final surface area is going to equal those two things added up. So that's 192 square root of 21 plus 384 square root of 3. And that would be centimeters squared. Know how to do that. Are there any questions on the bell work? All right, this is fair game on the test. We've done it in homework. This is only slightly different than the one we did in homework. All right, questions from the homework. Labib.
Number 4, on the answer key, so you put curve both the tall cylinder and small cylinder. You put 2 pi r squared equals 8.5.
Mm-hmm.
And then you had the radius equals 1.35. But where did the pi go?
The pi went, I just plugged in my calculator because it does say approximate your answers. So that's why I put it in stars.
Oh, okay.
So I literally divided both sides by 2 pi and plugged in my calculator. So I did 8.5 divided by 2 pi, which comes out to about 1.35. That's why I try to highlight this, because if we keep pi in it, it becomes a really hard problem. I wanted it, like, this approximate, I wanted it to be 63 inches cubed. I didn't want it to be 20 pi something. Okay, so I literally just put it in my calculator and just came up with about 1.35. Okay?
Yeah.
Okay. John.
Number 3.
Number 3. So number 3, we have 2 identical cylinders. In one cylinder, I took the base and created a cone that reaches the top. In the second one, I just have 2 cones on top of each other. And I was basically asking, how do the volumes of this one cone compare when I add these 2 cones together? Well, we don't have any numbers. So I just said, well, if I was going to calculate the volume of this cone, I would just do 1/3 pi r squared times the height. Well, my height is h. Well, for the other one, I would have this cone plus this cone. Well, once again, it's 1/3 pi r squared times its height. However, I didn't want to have a height that was like x and a height that was y. So I still stuck with the height is still whatever my h is. So I named the bottom one's height x, which would make this one h minus x. Like if this was 30, this would be, maybe this is 12, this would be 30 minus 12, so it would be 18, and they would add up. All right, so I just said this one's h, or this one's x, and this is h minus x on top. And then I did the formula. I said, okay, for the one that has height x, I'll do 1/3 pi r squared times x. And for the top one, I did 1/3 pi r squared times its height, which is h minus x. Then I took our x's and just brought them out front. So I just took that x and brought it out front. That gave me that x over 3, and I brought this one and put that in front too, which gave me h minus x over 3. Well, what happened here is kind of like if you have 2x plus 3x, you make it 5x, right? So I'm doing x over 3 pi r squared plus h minus x over 3 pi r squared. So I can add our coefficients out front. So what I did is I added this to that, which turned into x plus h minus x over 3. Where x is canceled out, I'm just left with h over 3, which if I put back over there turns out it's the exact same size as the original one. So if you have one cone inside of it or two cones stacked on each other, they're going to have the exact same volume. Sangha.
I have a question on number 10.
Okay.
How do you know the missing part is half size of the top?
It's kind of like if we bring that to 2 dimensions instead of 3 dimensions. So if I would have a square and then I draw a triangle on top of that square, and I said that this was 6 and this was 2 and this was 4. Well, I would do my 4 times 6 to get the box, and then I would do 2 times 4, but this is half of that rectangle. That is half of this rectangle here. So that's why the formula for our triangle is 2 times 4 divided by 2, because I'm cutting in half.
But how you know that's half? Is it like just half? It's like just half.
Because it's a triangle portion of a rectangle.
There.
Yep, if it goes from corner to corner, it's going to be half of this shape. It has to be. We're cutting in half. We're cutting this directly in half from corner to corner. The same thing happens when we bring it to the 3rd dimension. If you look at my answer key, I even try to draw on top of it what I was saying. That if I just focus on this slanted part, this cone right here that I kind of drew the top of, because it's going from corner to corner, it's half of the area of this, just this top cylinder here. Other questions? Yeah. Number 8. All right, I kind of picked the hardest way to do it, but it still is the correct answer. There's a much easier way to do this one. Well, it's similar, but we'll see it's easier. Okay, the whole logic behind this is to find the volume of something, it is base area times its height. Well, if we look really quick, let's just get rid of all this stuff down here. There. All right. So if we picture this, so say I picture this 13 by 16, I make that base. Make that my base. And I stack that on top. Would I get the entire shape if I stack that on top of itself? No. And now if I pick this big rectangle here and I stack it on top of itself, I'm actually going to get extra shape because that would turn into a box. So when you're looking for what is your base, you're going to look for the one that's reflected on both sides, where the base is the same on both sides. And that's going to be this wonky shape here. Because if I was to stack that on top of itself over and over and over, we would end up with that shape. So if I cut this one shape out and stacked it 15 times or something, I would get this same shape out, right? So this red shape is actually my base. That is my base, and I want the area of that. So I want the base area of this shape. Well, they give me some information. They give me this is 13. They give me that this is 14. They give me this is 30. They give me this is 4. So what I'm going to do for just a second, I'm going to treat this as just a rectangle. And then I'm going to cut out this triangle. So the area of this would be 3 times 14. And then we're going to subtract out that triangle. Well, that triangle is a right triangle. And since this is 13 and this is 30, this is going to be 17. And since we have 14 and 4 on the other side, we're going to have this is 10. So we're going to subtract out that triangle. So we'd have half of base times our height. And that would actually be the area of this red section. Now to get the volume, I just have to multiply by the height. But in this case, it would be the depth. It would be that 16. Yeah. So the big thing is when we're doing base area times height, the base should be the same on one end as it is on the other. That's how you're going to know which one to pick out as your base. Okay, yep. The other way you could have done this is you could have found the volume of the entire box, I guess you'd say, length times width times depth, and then found the volume of the triangle that you're cutting out, which would be base area of the triangle times its depth. Okay. Yeah?
If you look at a triangle going from the top left bit, that top left corner, going to the, yeah, you're up there, and then right where the 17 and the 13 meet.
Where the 17? Right here?
Yeah.
Yes.
And
So,
then have your base be 4, and then your height be 17. And then you do 2 times 17, which would give you 30.
all right. Let me. I lost you at one point. So you're saying draw a triangle here.
Yeah. Then
Okay.
have your base be 4, and then your height be 17
Base be 4 and height would be 17. Yes.
for the triangle. And then you get like 34.
And then you could find this triangle here.
No, and then you can find the trapezoid.
Oh, and then you can find the trapezoid. Yep. So if you looked at my example, so that would be perfect. My example on the notes, I actually split it into a rectangle, and a triangle, and add them together. So you just did a triangle and a trapezoid. Yep, however you want to get that area. I do think the easiest way is this way, probably. But however you want to, just tell me it's area times your height, or depth in this case. All right, yeah, but you're perfect if you got it all. If you did it right. All right, other questions? Bless you. It wasn't a question. I didn't ask for sneezes. Okay, then today, it's generally a pretty easy lesson. It is just a formula I'm going to give you. I do want to talk about something really quick, and that is something called a giant circle. A giant, or a great circle, I guess you'd say. Some people call it giant, but for our math book, it's great circle. Your great circle is the biggest circle that will go through a sphere. And the only way for it to be the biggest circle that goes through your sphere is that it has to go through the center of your circle. So your great circle actually cuts a circle in half. It cuts it into 2 hemispheres. So a great circle will always cut a sphere into 2 hemispheres, no matter where you draw it. If I would draw it going this direction, it would do a hemisphere this direction and a hemisphere that way. So anytime I'm talking about great circles, you should be thinking about half the size of a sphere. So if I say come up with the volume of a sphere cut by a great circle, it is just a hemisphere then. Yeah?
So it goes right down the diameter.
It goes right down the diameter. Yep. Then we're going to go right to the formula of a volume of a sphere. And that is 4 over 3 pi r cubed. The pi r cubed isn't too hard to remember because the area of a circle is pi r squared, so it makes sense when we get to the third dimension that it's pi r cubed. But you do have to remember this 4 over 3 on top. Davion, can you keep your head up? All the way up. All right. And this is hard to remember because what is the volume of a cone or a pyramid? John?
Third.
It's a third. It's a third base area. So you have 2 equations that have a third and a 4 over 3. So you really have to practice and practice and practice so you keep your 4 over 3 with your spheres and you keep your 1 over 3 with your cones and your pyramids. There's no nice trick way to solve this. This is actually calculus you need to actually solve for this volume, and I'm not going to teach you calculus just to come up with a volume of sphere. So I'm just going to give you the equation. It's 4 over 3 pi r cubed. Then we're going to do 4 quick examples. Our first 2 we're going to do approximates. Our next one we'll do an exact, and then we're going to do kind of a backwards one. All right, so it says find the volume of the sphere and approximate it. So our volume of any sphere is going to be 4 over 3 pi r cubed. So as soon as I know a radius, 3.5, that's just going to be something we're going to plug in our calculator. So this volume is going to be 4 over 3 times pi times 3.5 cubed. So in your calculator, you're going to do 3.5 cubed, and then you're going to multiply by 4 over 3, and then you're going to round to the nearest tenth. And as soon as someone thinks they have it, let me know, because then I can put it, yeah.
57.17.
17? Okay, so about 2.2. inches cubed. Yep, we do need pi. There we go. That's what I was looking for. So we have pi times inches cubed. And 2 people got that right? Anyone else? We got 3. All right. Then most likely we're right. All right, the only difference between this one and the next one is the next one gives you the diameter. So what is the radius of my next sphere? Labib. What was that? 2.1. All right, so our volume of this one is going to be 4 over 3 pi r cubed. Our r is 2.1. We're going to cube that guy. And what does that come out to? Labib. I want to the nearest tenth.
12.45.
Pi. And that was feet cubed. Yep.
Oh, feet cubed.
Yep. Can someone confirm that? I was looking for 2 or 3.
No.
We have a no.
12.3.
Yeah, it should be 12.3.
You gotta round down.
12.3. Are we okay with 12.3?
That's what I got.
Okay.
12.35.
Ooh, is 12.35?
This 12.348.
Oh, okay. Okay, yep. So we'd round to 4. Because you only round in one place, right? You don't round that 5 and then round that. Labib?
When you square 2 points, don't you just get 9.4?
So we do 2.3 cubed and then multiply it by 4 over 3. And I did get out approximately 12.3.
2.3. Oh, alright.
I think maybe you rounded it and then rounded it again.
Yeah.
You should only round it once with a calculator. You should honestly write 2.1 cubed. Take that answer and multiply it by 4 over 3. Don't round it.
Okay.
That's why you have a nice calculator. It can do it all in one string. On our next one, we do need to come up with an exact answer. They do give me my radius, but we need an exact, which makes this a slightly harder problem because we would have volume equals 4 over 3 times pi r cubed. Now, we have to reach back to how I cube a fraction. When you cube a fraction, so this right here, we can rewrite that as 3 cubed over 8 cubed. It is 3 over 8 times 3 over 8, which would be 3 cubed over 8 cubed. So that's going to give me 4 over 3 pi. 3 cubed is 27. 8 cubed, unless I'm completely off, is 512. Yeah, we're good. Okay. So now we're going to do 4 times 27, and we're going to do 3 times 512. Well, then we're going to have 108 over, what would that be, 150 plus 36. Did I do that wrong? No, I didn't. It'd be 1536. And 108 over 1536 actually simplifies. Does anyone have what that simplifies to? Yeah.
0.07.
I want to keep it as a fraction, though. I want the exact.
Oh,
Emma.
9 over 1.
As a fraction.
9 over what? 128.
One should be
Yep.
So you don't want it as a decimal?
I don't want it as a decimal because I think it says put it in your exact form. Exact form would be a fraction. If this said approximate, like 1 and 2, then we plug in our calculator and get a decimal. But since it says exact, I want a fraction that's simplified, and then I'm going to put my centimeters cubed after it. In fact, if you're not sure if something simplifies, you're more or less, if I say exact, leaving it as this versus putting it in your calculator and getting a decimal, because that shows me you didn't read the directions. But if you didn't simplify this, at least you read the directions. Maybe you just didn't see it could simplify further. All right, the very last one says the volume of a hemisphere is 6174 pi centimeters cubed. Well, I don't know the volume of a centimeter equation. I know the volume of a sphere. Equals 4 over 3 pi r cubed. How am I going to come up with the volume of a hemisphere then? Yeah. Not 1/4. It's just 1/2. A hemisphere is half a circle. A hemisphere is half a circle, so it's going to be 1/2. So if the volume of a sphere is 4 over 3 pi r cubed, then a hemisphere, so our volume of a hemisphere is going to equal, since it's half a circle, it's going to be 1/2 that 4 over 3 pi r cubed. All right, now what are they even asking me? They say that the volume of the hemisphere is 6174. So we're going to replace the volume of the hemisphere with that 6,174 pi. So you have 6,174 pi. Then the other side, I'm going to go ahead and multiply 1/2 times 4 over 3, which would be 4 over 6, which is actually 2 over 3. Pi r cubed. Then I'm going to go, okay, there's pi on both sides, so if I divide by pi, my pi would cancel out. How do I get rid of 2/3 from that right-hand side? Yeah. Multiply by the reciprocal. In this case, it'd be 3 over 2, right? So I'd multiply this side by 3 over 2. That says 3 over 3. 3 over 2, because that would cancel that out. And we'll multiply this side by 3 over 2 as well. And what is 6,174 times 3 over 2? Yeah. 9,261 equals r cubed. Does it ask you what your radius cubed is? No, it asks you for your r value. There's 2 ways we can get rid of that cube. The first way is we can take a cube root. A lot of your calculators have a cube root button on them, and I will walk around later and show you where that is. But we're going to take the cube root of both sides, and that should end up with 21 equaling r. So our radius is 21 centimeters. Another way you can do it, yeah. Like I said, I'll walk around and I'll help all you guys. Another way, if you don't know where your button is, another way to do this is if I had 9,261 equals r cubed, what you can do is you can raise both sides to the 1/3 power. Because your 1/3 and your 3 will cancel out, and all of your buttons have a caret. Every one of your calculators have one of those caret, those little raised to a power of, and you just have to raise 9,261 to the 1/3 power. If you type that in your calculator, you will get out 21 also. So if at any point you don't know where your cube root button is, just raise it to the 1/3 power. Just like it was to a 4th root, I would just raise it to a 1/4 power. It's a way to get around not knowing where your buttons are on your calculator. All right. Minus not knowing where your button is, because I'm going to walk around to every single group and make sure every one of you at least saw how to do it with their calculator once. Are there any questions on what we covered today? Okay, what I'm going to do right now is I'm going to walk around, make sure everyone knows where a cube root button is on their calculator or how to at least do this problem. After that, I'm going to check your homeworks, but the rest of the time is for you to work.